Hi there, welcome to Telefunken. Today, we're going to be taking a look at the keybed in a vintage Sequential Circuits Pro-One analog monophonic synthesizer. If you have a Pro-One that isn't playing properly, has noisy keys, skips notes, or double triggers, this video is for you. We're going to be rebuilding a keybed that's currently in more than 100 pieces. We'll be repairing broken keys, replacing worn bushings, straightening and cleaning the J-wires and bus bars, and when we're done, the keyboard will play as good as new. If that sounds like fun, stay tuned. The Sequential Pro-One keybed mechanism comes in two flavors. The first Pro-Ones, and the subject of today's video, came with the Pratt-Reed J-wire mechanism, named after the thin J-wires that, when pressed down by a clear plastic actuator, make contact with a bus bar to complete the circuit. These mechanisms were used up to serial number 8500 when they were replaced by a so-called membrane keyboard. Although both keyboards are known to be somewhat problematic, each requiring servicing from time to time, the J-wire keyboard has come to be preferred over the membrane version, and working J-wire Pro-Ones fetch a few $100s more than their membrane keyboard counterparts on the used market. For those of you who may be searching for a plug-and-play solution for a new Pro-One keyboard, you can purchase such a thing from the company Tex-Mex, who've adapted a modern FATAR keybed for use in the Pro-One. By all accounts, this is a great keyboard and should offer years of trouble-free service. It's currently selling for about 160 euros, roughly equivalent to 190 US dollars. Though I'm tempted to give the Tex-Mex keyboard a try, in today's video, we're going to restore the original Pro-One keybed and get it working again. Sourcing parts for the vintage Pro-One keybed can be challenging. The Pratt-Reed keys used in the Pro-One are quite unique, and they aren't being made any longer. In our case, we have a number of keys that we'll need to repair, but some others that are beyond fixing that we'll simply need to replace. A number of our favorite vintage synth shops do sell used keys from time to time, retrieved from Pro-Ones that are themselves beyond repair, but sadly, none of the usual suspects had the keys we needed in stock, so in this case, I was forced to turn to eBay, where used keys can be found for $10 to $20 a piece. Other parts needed for a Pro-One keybed refurbishment include the rubber bushings, which, being common to many different Pratt-Reed mechanisms, are thankfully easy to find. I've also had to source a few replacement springs and actuators, which are slightly less common but not completely unobtainable. Before we get started, I'll spend a minute talking about what the keys in the Pro-One are actually doing in the synth. Unlike a piano, where the key is part of a purely mechanical mechanism, the keys in a vintage monosynth have to perform multiple functions, and depending on the design of the synth, they accomplish these things in different ways. Obviously, playing any given key determines the pitch of the instrument, and this is usually done by selecting a control voltage associated with the pitch. In addition, playing a key generates a note on trigger or a gate signal that tells the envelope generator to start to let the note play. These various functions are accomplished by a system of buses, in some cases as many as 3 separate buses for each function, but we'll see in a moment the Pro-One is a bit smarter than that. Vintage synths typically use one of 2 different control voltage schemes to establish pitch. The most common, and the system used in the Pro-One, is sometimes referred to as the linear system, in which each 1 volt increase in control voltage is associated with a 1 octave increase in pitch. If we think about this for a moment, this is a bit of a misnomer, as this scheme is only linear when we map it to the piano keyboard, since, after all, each octave increase is actually a 2-fold increase in pitch. So actually, in this scheme, the frequency of the note increases exponentially with the increase in voltage. The second less common scheme, often referred to as the exponential system, is one where the control voltage doubles with each octave increase in pitch, as does the frequency. So if we plot this on the piano keyboard, we get an exponential curve, but in fact the relationship between control voltage and frequency is linear. The Pro-One uses the more common of the various trigger gate schemes as well. The V-trigger system holds the trigger voltage low until a note is played, at which point the voltage goes to 5 volts and is held there until the note is released. As I said, the Pro-One is actually quite smart in how it accomplishes all of this. The Pro-One is a digitally controlled synthesizer, controlled by the Intel 8021 8-bit microcomputer. With each read cycle, the microprocessor scans the matrix of switches established by the keyboard, which is arranged in a 5-bus by 8-bit diode switch array. With each key press, the CPU generates a unique binary number that's sent to the analog devices 80, 55/8 digital to analog converter. The DAC converts the key number to control voltage that is exactly 1/12 of a volt, 83.3 millivolts, per semitone to correspond with the 1 volt per octave scale. The advantages of this system, compared to the voltage divider network that's typical of earlier keyboards, is that the accuracy of the control voltages generated depends only on the scaling and operation of the DAC itself, rather than the sum of several independent errors resulting from a network of resistors and the resistances of the key contacts themselves. This means that the keyboard mechanism as a whole has less of an impact on the actual sound that results from any individual key press, and the system is less sensitive to drift in individual component values. The microcomputer is also responsible for generating gate and trigger signals, and it's through the use of the microcomputer that the Pro-One can store short sequences and affect arpeggiation. Another vintage monosynth with similar capabilities afforded through the use of a microprocessor is the Roland SH-101. So without further ado, let's dive right in and see if we can rescue the keybed from this Pro-One. Well, here we have the Pro-One keyboard, and as you can see, it's in a number of pieces, some of them a little smaller than others. And I'm filming this to really give you an idea of the challenge that is before us. What we have is a Pro-One Pratt Reed J-wire type keyboard assembly. These are the J wires, and all of the keys have been taken off of it, and we have the various parts, the component parts, which include these little rubber actuators and various springs and other elements. As you can see, some of the keys are actually not in great shape, and this type of key, this Pratt Reed key, has a number of elements which are subject to breakage, and they include this post which pushes down on the actuator, connects to and pushes the actuator, which actually moves the J wire. And this post is pretty famous for breaking right off. And here we can see a C key where that post is broken. Another part that seems to want to break is there's a little nub here which attaches to the spring and pulls the key back into position, and the spring hooks over this, and it is actually broken off on all three of the E keys on this keyboard. Another thing that'll break is this little shelf part here, and we can see a chunk has come off of this key here. There's another one that's broken, another one that's broken there, and I'm not sure how I can explain this sort of breakage, but we do have a key that's completely busted up. I'm not even sure if we could figure out how to piece this together if we wanted to. So we have a dilemma, and that is, what do we do about this? They don't make these keys anymore, although there are some people that are trying to 3D print these things. So they're quite difficult to obtain, and they weren't terribly common. They're not a terribly common version of the Pratt Reed key. And so really the most common keyboard that you'll see them on is the Pro-One with this J-wire keyboard, and they made the Pro-One with the J-wire and a membrane keyboard. So again, that contributes to their relative rarity. So I'm going to try to identify a source for replacement keys, because in my mind we need at least 2 keys replaced here. This one most certainly, and probably this one as well. Even though you won't see this damage from the top of the key, I'd still like to get that fixed. The rest of the damage, I think I'm going to try to attempt to repair. And what I'm going to do is attempt to put in rather than simply trying to glue these back on, these broken pins, what I'm going to attempt to do is to actually drill this out and insert a screw from the other side that I'll be able to use as a replacement actuator. We'll see how that works. That'll require a little bit of glue as well. And then similarly here, where we're missing the part that we would hook the spring onto. I'm going to attempt again to drill out a hole and insert a pin that I can then glue in from the back of the key and hopefully effect a repair that way. There are other aspects of this that require repair, and that includes the J-wires themselves. And I'll zoom in a little bit. So these J-wires are actually meant to be on the other side of this bus bar. It's a single bus bar system, and the J-wires are underneath, and when pressed down by the actuator, the J-wire will contact the bus bar, and that closes a switch which is sensed by this diode array, which goes to our computer that tells it which note to play. And these J-wires are all bent, or many of them are bent, and I'd prefer to sort of straighten this out a little bit. They're also filthy, and I want to clean them and make sure that we're getting really good contact in all the areas that require it. Now, all this may be for naught, in the sense that if I'm not able to source the replacement keys, I'll be out of luck. But in addition, I may find that a more fulsome repair, which would be facilitated by replacing all of the keys that have structural damage, may be required and may be cost prohibitive. So I've done some rough math and looked at the cost of replacing all of the keys that have problems, and there's about 11 of them or so, and if they run at $10 to $15 to $20 each, that starts to add up. In addition, the bushings on the assembly that require replacing, and these are them. These are very old and brittle now, and I'll need to replace these. They have a cost associated with them. You can see this one's just ready to crack into pieces. They have a cost associated with them, and so that'll contribute to the overall cost of this little project. The springs that are missing, because there are a few springs that are missing, and the actuator that's missing, again, all contribute to the cost. And that cost will closely approximate the cost of a replacement keyboard that I'm contemplating, which utilizes a modern FATAR brand new keyboard and pops right into place in the Pro-One. As much as I'd like to keep this essentially original, it may not really be the smartest thing to do. But either way, I think what I prefer to do is get this keyboard up and running, because they're not making new old stock Pratt Reed J-wire keyboards anymore. And so the more of them that are around and survive, the better. So I think I'd like to take good care of this one, do what I can to get it working, and then weigh whether or not I want to utilize the modern replacement or not, based on my own future plans for the instrument. So that's it for now. A little bit of an update, and I'll get back when I have some progress. I have washed all of the keys, and as I mentioned previously, we have a number of white keys that have issues and that they have broken in various ways. Each of these keys, these 7 keys, has a problem that I'm about to attempt to fix. And the problem is either with this pin, which hangs down from the key. And what this pin does is it actually presses the actuator that moves the J-wire up and down when you push on the key. This little actuator is making the J-wire come into contact with the bus bar, and in a number of cases this off. So what I have done in order to address this is I have prepared these keys for a fix. And what I've done is I've initially taken a soldering iron and put a tiny hole through this point where this pin would normally be, because the pins break off about 3/4 or 7/8 of the way down towards the key. I've poked my soldering iron through to make a hole in the correct location, and then I've expanded that hole with increasingly large drill bits.
until I've gotten to about a 1/8 inch diameter. And why 1/8 inch? Well, if we look at the diameter of this pin, it's about 3.17 millimeters, or about 1/8 of an inch, essentially 1/8 of an inch. And 1/8 of an inch also happens to be the diameter of these screws that I have. These are 6/32 1/8 inch diameter screws. And what I've done is I've taken some of these and I've cut the ends off of them, and I've trimmed them up slightly. And I've made them the appropriate length so that when they are screwed and glued into this hole, they will protrude just the right amount, such that they'll serve as an adequate replacement for these pins which have broken off. And again, you can see that the diameter is appropriate and that they will hold these actuators just fine. In fact, the actuator can be screwed on if you like to get it into exactly the right position. So that is how we're going to address one of the faults in these keys. Another fault is in, for some reason, each of the E keys. I don't know why just the E keys, but you'll see that the rest of the keys have a little pin hanging off the back of the key. And this pin is so that we can attach the spring, which brings the key back up after it's been pressed down. So you press the key down, this spring pulls it back up. And for some reason, on the E keys, maybe the previous owner was playing a lot of E notes, these pins have broken right off. And so we're going to take a similar approach, and that is one where we have drilled a hole to take a replacement pin. And in this case, what I've done is I've taken a number of screws and I've ground the heads slightly. And these screws are actually 3 millimeters because this little pin on the back just happens to be about 3 millimeters, 3.24. So these are 3 millimeters, and I've ground down the tip, or rather the end of the screw, so that it's more rectangular, and more importantly, it's quite narrow, such that it will fit in this space here. And what I'm going to do is put these screws through this hole from the inside of the key out, glue it in place, and this screw will take the place of that plastic pin, which is subsequently broken off. This is a little trickier because for some reason when the pin broke off on each of the keys, it's taken a chunk of plastic along with it. And that's the area that I had to drill through. And that one's not quite as bad. That's the area that I had to drill through. And so we'll be mindful to try to reinforce this by not only gluing in the screw, but maybe putting a little extra glue around that area. And there is plenty of room. We need to leave the area here where the key hinges up and down on the case. We need to leave that clear, but the rest of this this void can be filled with glue if we so choose, in order to reinforce the key. So I'm about to take care of this and go from there. As I said, I've just washed all of these, so they're actually just still drying. I'll do these pins first, but my intention is to actually use cyanoacrylate initially, and then maybe after the cyanoacrylate has dried, come back and use maybe some epoxy to reinforce behind it. And I'm just drying this, make sure that it's completely dry before I try to glue on it. There is some kind of glue or something that was on many of the pins. You can see it here. And I'm speculating that the actual actuators were glued in place either at the factory or subsequently during servicing. I'm not sure. I don't think they should have been by default at the factory, but could be wrong in that assumption. Okay, so and part of the cleaning was removing the debris from the old key bushings. The key bushings will fit into this space here. You can see a little bit of remaining debris here. I want to get as much of that out as possible because that's just going to interfere with the action of the new bushings that we're going to be installing on the keyboard. So rather than trying to get the glue everywhere, I'm going to just put a little bit of glue on a piece of tape and then use a toothpick to apply it where I want it. And I was careful to make these holes big enough because what we don't want to be doing is stressing this plastic and causing it to crack after the fact. So these should screw in quite easily. Of course, it's made a little bit more difficult by virtue of the fact that there is no head on this screw any longer. We want this straight up and down, but this is not, as they say, this is not rocket surgery, nor is it brain science. This is a pretty simple mechanism. Okay, so that's essentially exactly the same level as the other one on the other key. It'll take a little while for the cyanoacrylate to dry, and it's pretty darn straight up and down. So we'll just set that aside. The screw is protruding ever so slightly from the other side through this little bracket that holds it in place, and that will give us an opportunity to reinforce this with a little bit of epoxy later. And we don't really care about what's on the other side of this because this doesn't touch anything, it doesn't do anything, so we can reinforce that to our heart's content. Moving along. Don't want to dilly-dally too much with the glue sitting here. This is Gorilla super glue, which has a thickener in it, which sometimes makes it a little easier to work with because it doesn't flow quite as much as pure cyanoacrylate glues do sometimes. Okay. Another one. Okay. So we'll move on to the end pins now. And if we compare these here, you can see that the new pin is protruding roughly the same amount as the previous one, and hopefully that will do the trick. Two more here. Here we are. So this may seem like a lot of work and is maybe a bit of a hack in that it might be best really if we can replace the keys with new ones. But we're not completely sure we're actually going to be able to find new keys. They're not exactly falling from the sky or growing on trees. So anything we can do to keep these keys in service is probably a good thing. Another aspect of this is that even if we do find replacement keys, or if we could find replacement keys, there's no guarantee that the replacement keys will be exactly the same shade of, I guess, ivory, given that they may have come from another instrument, a used instrument that has been in a different environment, perhaps one that's been in a smokier environment than this keyboard, and so on. So you find that on the used market, oftentimes the keys are of various shades of ivory, and so they won't necessarily match your old keyboard. And this is another reason why, if at all possible, we probably want to stick with the original keys. So I'm just using up the remainder of this cyanoacrylate. So that's it. Once these dry, they are ready to put back onto the keyboard, and they should work just fine and have saved us somewhere between $10 to $20 per key, in that we haven't had to go out and source a replacement. So this is the, I don't know, frame, I guess, for the key bed, with the bus bar, the J wires, the diode array, etc. And then this is the top. The keys sit on it like so. And then these are the bushings, and they slip inside this cavity here, like so. And the key sits, where are we? Key sits here, and when you push on it, the key is essentially moving up and down on this bushing like so. The key is pulled back by the spring, and that's the extent of the key action right there. These key bushings are supposed to keep these keys nice and secure and keep them from flopping around and or scratching against each other. And they're supposed to be kind of soft, pliable rubber, but they're not. I'll try to get one off here. Shouldn't be too hard. They're not soft, pliable rubber. They're dry, brittle, crackly rubber. And as such, they're not doing their job. And so we need to get them off. And so there's different ways to get them off. Some people say, oh, you should try cut them with an X-Acto knife. But you'll see that what I had just done, twisting them from side to side, seems to work reasonably well in terms of getting them off the mechanism. And that's really all we want to do here. We're going to take them off, replace them with fresh ones. So we want to take them off and clean them. You may notice that these tines that the bushings are pushed onto are uneven. So if we if we look down the keyboard, some of them are much higher than others, and this is going to be part of this service, is making sure that they're all in the right position and that all the keys on the keyboard, when we're done, are sitting level and all have exactly the same type of action. So these are now 40 years old, so maybe not a huge surprise that they're falling apart. When these get put back on, they get lubricated, and it's important to choose the right kind of lubrication, because if you choose the wrong kind of lubrication, if you choose a lubricant that is absorbed by the rubber will actually swell and press against the sides of the keys, and your keys won't have a nice soft action. You'll have to press them quite hard in order for the key to play, and we don't want that. So we'll make sure we use the right lubricant, and I'll describe that later in the video. Yeah, these really are not doing us a lot of good in this condition. They're also part of the, I guess, silencing of the keys, because when they're in actual contact, they dampen vibrations that might occur otherwise when you're pressing up and down on the keys. Yeah, but in this condition, they're not really doing that. So I'll clean this up a little bit more and prep it for the new ones. And another thing that I need to do is straighten these and clean the bus bar. And I may actually disassemble this whole thing in order to do that. Although one good reason not to do that is that if I disassemble it, I might be tempted to start painting it, which is a whole project into itself and doesn't really do us any good. But it's the sort of thing I I'd fall down that rabbit hole if I wasn't careful. Okay, so that's the removal of the bushing. So this is our key bed, and it's not in the greatest of shape. Obviously, all the keys are off of it, and as we've described, we've done some repair of various elements of the keys that were broken. We've now also secured a couple of replacement keys for that were broken beyond repair, and we've even got a couple of extra actuators and some replacement springs to replace springs that we didn't have. But you'll see that some more needs to be done because the J-wires themselves are very bent. They're damaged, and no doubt they're kind of corroded, so we need to clean these up. But first things first, we're going to undertake a bit of a electrical check, and we're just going to examine all of the diodes in the key bed. So we'll put the multimeter into diode mode. What we're looking for is comparable diode drop across each diode. And so here we have 0.671. And of course, we should have an overload in the opposite direction. And we do. So 0.671. And if, for example, we weren't able to get a diode drop, if we had a blown diode, we'd want to know about it before we put the keyboard back in the instrument. 0.661. We're just ensuring that these are working as diodes. The specific diode drop is less important. So there we go. There's one or two diodes that seem a little tired potentially, but other than that, they all seem to be behaving as diodes. And so now we're looking at cleaning the J wires and the bus bar, and then reassembling the keyboard. It would be very nice to be able to replace these J wires with fresh ones. None of them are actually out and out broken, but they are rather bent. Unfortunately, I've not been able to source J wires at a reasonable price. And in order to replace all of the J wires, which is what I would do in this instrument, we'd be looking at a couple of $100, and we can get a new modern replacement keyboard for close to that. So we won't be replacing the J wires. We're going to do our best to straighten them and go from there. So without further ado, I will set out to do that. So in order to get at the J wires, which are, of course, on this side, and more importantly, to get at the business end of the J wires, which is the bottom side, we really need to take the J-wire assembly off of the key bed assembly. And the way that is done is by pinching these little clips here carefully so as to not break any of them, giving them a little bit of a pinch and a little bit of a push to get them to come through the board, or rather the metal assembly that holds them in place. And is that one necessary? No, that's actually the bus bar mechanism that I just released there, but I need to release that as well. So we need to take all of this apart, but starting with the J-wire assembly, and then we can begin to actually clean the J-wires gently. Gently being the operative word. Again, we squeeze these lightly and give them a little bit of a push, and we want to be quite gentle because in some cases these can become quite brittle. I think it depends a little bit on the environment that they were in. You might benefit from doing this in a warmer environment rather than a very cold room, because the plastic will be just a little bit more flexible and less brittle, because we don't want to be breaking these attachment points. There we go. There we go. There should be no bits of plastic, especially broken plastic. We can set that aside. So obviously, if we were replacing J-wires, what we would be doing is desoldering them from these positions here and putting in new ones. We don't have new ones. We're not doing that. But we are now going to be able to clean all of these J-wires and more importantly, the surfaces, the business end of the J-wires and the bus bars. The bus bars, the J-wires sit on top of the bus bars and will press down on the surface that's exposed and is particularly filthy. We can see a little bit of some positions where tarnish has been eroded, let's say, at various points. I don't know if that's obvious to you folks. And that's where keys have been pressed repeatedly. But we want to remove all the tarnish from the bus bar and as much as possible from the J-wires. And what I'm going to be using for this is not this. This is a brass brush, but rather I'll be using this, which is a fiberglass brush. And it's about as aggressive as I ever would want to be with something like this. So I just give the bar a few strokes with this to clean it, and that's about it. So you can see very tarnished, very dark. It's quite an improvement already. There we go. That's quite a lot of tarnish removed there. I can see the metal now glistening, whereas it certainly was not before. Now, the J-wires are for the most part on the wrong side of the bus bars. And so we need to move them. But before we do that, we're actually going to clean them while they're on the wrong side, because that's a heck of a lot easier. So again, very similar operation. We clean them simply by going like so. And this is actually, this works quite a bit better. It's actually a lot easier to clean the J-wire, except I'm doing it the wrong way. They get cleaned on this side because they go on the other side of the bus bar and get pressed into it. So this is the side of the J-wire that we want to clean. And that's the sort of thing that we do. We just brush it 10 or 20 times until we see that the tarnish is gone. And I can see that. You probably won't be able to see it from where you are, but I can see a definite difference in the shine on that wire. And then we reassemble the whole thing and go from there. So I have cleaned the J-wires and the bus bars and set everything up ready to go with the bus bars on the right side of the J-wires, with an exception. Yeah, see this guy here? He's on the wrong side. Ha! How did he get over there? So this isn't the end of the world. You simply just get him under there. And I've also put these little actuators on. They're probably a little easier to get on now than later. And we're more or less ready now to put the bus bars and the J-wire PCB assembly back onto the mounting bracket. Somebody's burning donuts out in our street. Yeah, so I've put the actuators on the PCB assembly because it's a little easier to do now than it might be once we've got this remounted. And we're ready to mount it back on the bracket that holds the whole keyboard onto the synthesizer. And the way this goes on is you simply put it back on the way you took it off, which means you line up the holes where these guys go, where these holders go, and push them in, and that's that. Now, one thing you might want to do before you set about reassembling the keyboard is taking a look at this bracket and these surfaces where the keyboard bushings will actually mount, and line them up a little bit. These were all higgledy-piggledy, so to speak. So if you look at them in a line, you should see that they're more or less kind of lined up. They don't have to be perfectly aligned, but this is going to be the stop point for the keys. As the keys get pressed down, the bushings will be mounted on here, and this will determine the height of the key. Now, it will be slightly variable depending on the strength of the spring and the fulcrum point and so on and so forth. So you don't have to get these perfect because you do adjust them after the fact. And actually Pratt Reed sells a little tool that will facilitate that. We don't actually have that tool, so we're kind of out of luck. But nonetheless, we're going to do our best without it. So this is the way the whole thing goes on. The mounting studs go in these holes here. The bus bars are on the upper surface, the J wires below them, and the actuators will all go into these little holes, and that's where the keys will actually stick through and be pressing the J wire up against the bus bar when the time comes to actually play a key. One of the things you may notice is this side of the bus bar is actually pretty dirty. If you look at that, you should be able to see a bit of tarnish there, whereas this side of the bus bar should be quite clean or relatively clean in comparison. When you do all of this, make sure you don't lose these little plastic guys here, these little black plastic things. What they do is they try to line up the connectors so that they are properly aligned, and go from there. See, I've already got a J wire on the wrong side of one of these connectors. Again, not the end of the world. You just move things around. You do have a certain amount of play in the system, so to speak. Here's another one. And even once you've got a bus bar mount in the keyboard bracket, you can still move the bus bar back and forth to get it lined up with its neighbor. Now, in spite of the fact that these keyboards have a reputation, and the reputation, I think, is one that suggests that they're kind of a pain in the butt and they require a certain amount of maintenance. That may be true, but the flip side is that they're actually kind of hard to break. The moving parts that are in them are actually pretty simple, and so you don't necessarily have to be super scared of embarking upon this sort of endeavor yourself. It can be a bit of work, but if you own an instrument with a keyboard like this and it's not behaving itself, you might be amazed at what kind of improvement you can get through this sort of maintenance. It's not that complicated. You're probably not going to break anything. It's not like it's not like soldering sensitive, irreplaceable components, unless you, of course, are soldering on your keyboard. But suffice to say, yeah, these things are more robust than their reputation may belie. Oops. You'll notice that the way that I have put the actuators on is that each actuator is on a J-wire through the middle hole. That can be adjusted after the fact, again, to improve the action if required. But that's going to be our starting point. So those are the bus bars mounted. We're about to replace the bushings on this Pro-One keyboard, and you're going to need a couple things in order to accomplish this. One is you're going to need a set of bushings, and these are widely available from various vendors. The ones that I have here were acquired from a company called Vintage Vibes that specializes in Rhodes pianos and instruments of that nature, but they were the most affordable vendor when I recently searched online. You'll also need a little bit of lubricant, and in particular, you're looking for a silicone grease, a light silicone grease. And Vintage Vibes is kind enough to offer to provide you with this as part of their product offering, and they also include a handy-dandy little brush to apply the lubricant, which makes life a little easier and a little less messy. The actual bushings themselves, this is hopefully a close-up that you can visualize. They are asymmetrical. If we examine them, there's a wider side and a more narrow side. And the wider side is to be oriented such that that is up, and the narrow side is down on the tongs that protrude from the mounting mechanism. And this is because the most firm action that the bushing is going to experience is when a key is pressed down. And so we want the maximal surface area to cushion that available to the bushing. And what it's pressing against is the inside of the key. The key actually sits here. It sits here on the keyboard, and this little tong here is preventing the key from moving too far up as it's being pulled down at the back by the spring. And then when it's pushed down, the key and the bushing is stopping the key from moving any further than this. Of course, the actuator, it will be attached to this part of the key, and that will be moving the J-wire on the other side. And so we want the widest part of this bushing to be on the key when it's being pressed down. So after cleaning this of the remainder of the old bushings, you simply pop the bushings on and making sure that it's in the appropriate orientation. There's no front and back. There's an up and down, but there's no front and back to the bushing. And again, just as an illustration of what this bushing is doing, here it is kind of dampening the action of the key as it moves up and down, and in particular when it's being pressed down. And it's preventing it from moving from side to side as well. And so that's what these things are doing. And if you have a clack, it's likely because these bushings are indeed worn out. And I'll just show you very quickly. Hopefully, you can see this part of the key here is hitting that bushing, and the bushing is properly oriented on the key such that there's a little bit protruding in front of the key and a little bit protruding behind that part of the key. And that's what we want. Okay, so we'll just
gently and patiently apply the bushings, and then we will turn our attention to their lubrication in just a moment. Sure enough, I put this one on upside down. So there we have it. The bushings are installed. You'll notice I pulled this one off. It's because it has a little extra sort of schwarf from the molding process. I assume these are molded. And I just didn't want that on the keyboard or keybed. And you'll also notice that I have a few extras. That's because I ordered 44 of these guys. See, 44, instead of the amount that was required for the Pro-One, just to have a few extra kicking around. So that's that, and we can now set about to lubricate our bushings. And this is going to contribute to the kind of dampening mechanism, because it will modulate the degree of friction that the bushings themselves are exposed to. It's important to use the right kind of grease here. If we use the wrong kind of grease, what we may end up doing is sort of accelerating the degradation of these bushings, which are, of course, rubber. And we don't want to be doing that. We prefer that they last a long time. But I'm sure that you've seen rubber products which have been exposed to solvents and the like, and they can become quite hard and brittle. And that's what would happen if we were to use the wrong kind of grease or the wrong kind of lubricant. So, for example, my understanding is that the rather ubiquitous WD-40 should not be used on these because it may accelerate their degradation. If you have any guidance along those lines, please feel free to add it to the comments. So once you believe you've applied grease to all of the bushings, maybe flip it over and have a look on the other side and make sure you haven't missed anything and that there's grease on all of them. And we'll just quickly look and see if there's any horsehairs hanging on here from the brush and try and get rid of those, because they're certainly not going to help anything. And now we're ready to begin to put the keys back on the keyboard. And we'll start with lining them all up in the appropriate orientation. Well, we have all of the white keys laid out in order, which helps us with a couple of things. It helps us make sure that we have actually got all the keys, and it'll help with the positioning. I haven't put the black keys in any particular order because there is no order. They're all the same, and so we don't need to pay too much terribly attention to which black key goes where. Just again to remind people, this is one of the repairs that I've made to the keys, is replacing this broken post with a screw. This is another repair that I've made, replacing one of the broken posts on the back with, again, a screw. And this is a part of the key that experiences quite a bit of force as a result of being pulled on by the spring. And so again, I've reinforced that with epoxy on the inside. And I've replaced a couple of broken keys. This is an example of a broken key. And although this may not have been terribly visible, unless you looked underneath the instrument, you wouldn't really be able to see this broken part. One of the keys that I secured from Japan at rather great expense is replacing this broken key. So all the keys will look perfect and function perfectly well. And one has to be mindful that this key here, this high C, is quite rare because it's unique in its shape. It's the only C that has this kind of shape. The others are more narrow, and accordingly, you really don't want to be busting this one. And without further ado, we'll begin putting these keys where they belong and go from there. Just get that out of the way. And you'll notice the little mistake that I just made. Well, I guess it's not that little. It's a mistake. You need to put in the black keys first. Otherwise you can't get them in. So just keep that in mind. Well, we have all of our keys on the key bed, but there's not a lot holding them on other than the part that hooks over the bushing. What we need to do next is make sure that we get the springs on and get them on properly. And the way we do that is we have two different kinds of springs, and these springs are going to have slightly different tensions. We have the blue spring and the red spring. The red spring is for the white key, and the blue spring is for the black key. And the easiest way to remember that is B for B. And the springs are asymmetrical. Well, first of all, why do we care about the different colors of springs? Well, they're actually, they have different spring tensions. So the spring for the black key rather, has less tension on it than the red spring for the white key. And that's because there's less leverage required to pull this key into position than required to pull this key, which weighs more and is longer, into position. These springs hook onto the bottom of the key bed, the key bed frame, and they hook on through a little notch cut in the key bed, and then and this is sort of a J hook type arrangement that clasps onto the key bed frame, and then the spring is pulled up onto position on top of this little post that hangs out the back end of the key. And when you begin to do this, that's when you'll discover just how much force is being put onto this post here, and why these things might actually break from time to time. So I will attempt to position one of these and hopefully regale you with my skill in this regard. So grasping the spring, hook it onto place, hold the key in position. Hold the key in position while pulling the spring and hopefully lifting it up and hooking it over. Again, there is a specific Pratt Reed tool which has been designed to facilitate this very operation. I don't have that tool, but there we go. That's the key in position. You'll probably hear quite a loud little click. And that's going to pull the key up, and that's exactly what we should expect. So again, the blue spring goes on the black key, and we position it such that the J hook is facing away from us. Hook it on to the key bed. We can get it in there. There we are. Pull. There we go. There's the next key. And repeat. So that's all the keys attached to the keyboard or key bed, and the action is beautiful, I have to say. It really is, and almost silent. And at the same time, this keyboard is completely non-functional at the moment. And why is that? Well, if we turn it upside down, it's because these actuators are not connected to the keys. And so that's the next step, is to ensure that the actuators are connected and that all the J wires are aligned such that they're connecting with the bus bar at the same time when one presses a key, because we don't want premature triggering or relative to other keys. We want uniform triggering across the key bed. So we'll now set about connecting all of the actuators, simply pushing these down. Now, various people use various techniques here, such as glue, to hold these in place. I'm not sure that we're going to be gluing these yet. We'll see how firmly held in place they are without any glue before we go there. Some people use glue, some people use Loctite. There are various approaches that can be used. So you can see here, I've just connected 3 of these. And now when we press on the key, the J wire will connect with the bus bar. And that's how we actually trigger a key. We don't want any J wires connecting with the bus bar unless the key is played. We want all the J wires connecting with the bus bar at the same time, or the same portion of the key's actuation, if that makes sense. So we can see, for example, this key, this black key here. If I press on it, the J wire is actually not contacting at all. So that key just simply won't play. What needs to happen is the J wire needs to be bent. And I believe it's got a bit of a curve to it. It needs to be bent, and or the J wire needs to be repositioned on the actuator. These other black keys, this one suffers from the same fate. This one is playing, this one is playing, this one, same fate, etc. And there may be some white keys. This white key, for example, is not going to play with the J wire in that orientation. So we're going to make some adjustments until we get this right. And I'm putting on gloves for this part of the operation because I don't want to be leaving oil and whatnot from my fingertips on the J wires or the bus bars.
So all these keys appear to be playing properly. So when we put this key bed back in the keyboard, we should expect good performance. Okay. A couple of drops of contact cleaner, just for good measure. And we're ready to go.